Hello everyone and welcome to this video on virtual memory, paging and mapping techniques. We will be discussing onto this one. This is a series of videos under the course of digital design. In the previous video, we have discussed on different memory concepts starting from memory classification. Then we have discussed on cache memories, virtual memories, associative memories. So in this video, by this one, we will be completing the memory part. There is nothing but the virtual memory. And how the paging concept is there, how the mapping techniques is there, that we'll be discussing. So once again, before we start this concept of virtual memory, I will be telling you over here what is the memory hierarchy. Once we'll discuss the memory hierarchy. So in the memory hierarchy, you would be having an main memory would be there, main memory. Then you would be having some as auxiliary memory or external memory, we can say. And in this one, you would be having a cache memory. So cache memory in the previous video, we have seen about what is a cache memory, how the cache memory has been there. And before to that one, we have discussed on associative memories. Associative memories are a different type of memory. Okay? It is not the hierarchy of memory. And virtual memory is somewhat similar to the concept called as, maybe to say, associative memories. So in the memory hierarchy, you would be having either it would be a cache memory, main memory, or auxiliary memory. Auxiliary memories are nothing but the secondary memories or the outside memories which like a magnetic tape, magnetic disk, you can have on a hard drives, all this one will be coming in auxiliary memories. And cache memory is an internal part where you are when your when a CPU wants to read a data, it could be referring to it to the cache memory. If a cache memory contains the particular data, then reading of data to the CPU would be very fast and it can read it very fast. So that is the concept about the main concept behind when you say the cache memory. And if a data is not available in the cache, it will be going to the read in the main memory. So this part is a different part. And auxiliary memory are nothing but main memory data is not sufficient, it will be going to reside into the auxiliary memory. So sometimes auxiliary memories or associative memories are somewhat or more or less related to the virtual memories. The virtual memory are nothing but we can say the address used by the programmer. Okay, it could be creating a virtual address. Suppose if your programmer is going to set it up at 20-bit address bus. So you would be having a 20-bit address lines and the associated. And this set of address is called an address bus. In the main memory, you would be having a set of data under the main memory. Suppose if you had a memory, in the main memory, you would be having a set of data. Data would be there in this main memory. So the address, or we can say the address in the main memory is represented by a physical address. That means to say the address is physically available. So that is the actual address, but here we create a virtual environment where you had a plenty of large set of data. Assume something. So that is the nothing but the virtual memory. So the address used by the programmer is called as address, virtual address. And set of search addresses is called address space. Remember this one. The address in the main memory is called location or physical address. This is in the main memory. This is set by the programmer. The address used by the program. The set of search addresses. Search addresses means the addresses of uh, memory are called as memory space. For example, we have taken it as 32 32K words needs how many? 15 bits. I have given one tabular column where one bit takes 2 bytes, 2 bits take 4 bytes, 3 bits will take 8 bytes. Like that way you could proceed it up. And if you are having 15 bits, if you are having 15 bits, it will take 32K. So like this way, an auxiliary memory capacity of 1024 words equivalent to how much? 32 main memories. At all, you are having an auxiliary memory of 102K words, and it would be now. We will be going for 20-bit address, virtual address. What would be that one? We'll discuss it up. So let's say this is an auxiliary memory and this is a main memory. If a auxiliary memory data is there into the main memory, it will be brought into the main memory over here using of this address space. So this is about the address space. 101 megabyte of memory is auxiliary memory is very large. We are having a large auxiliary memory. 1024K. 1024K means how many memory segments are there. So that is the memory space would be 32K. Memory space is what? 32K. Auxiliary memory space is what? So you can't, this is the auxiliary memory which you can't be embedded onto the main memory. So only a part of that one, which is nothing but 32K, or some part will be brought up into the main. The virtual address and the mapping concepts comes over here. When you see here this block diagram, you can find that the virtual address is of 20 bits. So you will be having 20-bit address bus, virtual address, and the mapping table will give you how the mapping of virtual address is being done and how a mapping is done to the main memory, and from the main memory how it is read to the another memory, how the memory address will be there. So this is the main memory. What are the addresses to be put up in the main memory address? It will be give it up and it will mapping will be done. So address mapping using of pages. Pages is nothing but a short block of memory or so information in the address space. Address space means what? Virtual memory address space and memory space are divided into group of fixed sizes. Space is defined to virtual memory and memory space is defined to the main memory over there. So the physical memory broken down into group of equal sizes called as block. So the total memory is been broken down into three. It has been divided into equal size blocks. The term refers to this group of address spaces of same size. Block size is equal to page size is equal to 1K. Main memory, for example, we'll take this example and we'll conclude it up. Block size and page size is 1K. Main memory capacity is what? 32K. It is divided into how many blocks? 32 blocks. Auxiliary memory capacitor is 1024K. It is divided into 1024 pages. This is the example you can have it up. So the pages from 0 to 7 are given and the blocks are from 0 to 3 according to that. So the mapping technique is being done like this way, using of pages, how the data is being taken up into the virtual memory, into the main memory. And one more thing is that in the main memory or the virtual memory, we can go for block numbers can be transferred to the main memory, and presence of a bit number 0 or the content of word referred to the virtual addresses does not reside in the main memory. So all the call in a operating system is generated and it's fetched in the main page and it. So these all are internal process. It will be going on smoothly and the data from main memory and the virtual memory will be taken. Virtual memory is a large memory, remember one concept, and main memory is a smaller memory. So one part of data, if you take it from the virtual memory, how it will be feed to the main memory, that would be the memory. The disadvantage is that random access memory pages is inefficient with respect to storage location. For pages like 8 and block 4, block 4 presence in bits are not empty. And totally, suppose for 1024 kbytes address space, 1024 pages of 1K, 2K of memory space has equal. Find how many locations are empty using address mapping by pages. Thank you for watching this video. Next video we'll be discussing on PLDs.